Don Machholz, and you are listening to Looking Up with Don. This is Looking Up with Don, podcast episode number 9 for the week of March 4th, 2020. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com, 2 H's. So, what's up in the sky this week? As our week begins on Wednesday, March 4th, the moon is just past first quarter in our evening sky. Over the next week, the moon will grow brighter and more full each night, reaching full moon on Monday, March 9th. This is a good week to get out and look at the moon, and we'll be doing that later in the podcast. Venus hangs out in our southwestern sky. It passes 2.3 degrees north of the planet Uranus on the evening of Sunday, March 8th. While Venus and Uranus are in the western sky, there will be a bright moon in the eastern sky. Nevertheless, try to get out there and see Venus through your telescope 2.3 degrees north of the planet Uranus on March 8th. And once again, take a look at the star Betelgeuse. Even with a bright moon in the sky, it's still possible to make a magnitude estimate of its brightness. So what's happening to it this week? A couple of reports lately are that it has stopped dimming and is starting to brighten again. But what do you think? Use map 1 for podcast 9 to make an estimate of the brightness of Betelgeuse. In the morning sky, we can see the planets Mars, Jupiter, and Saturn all in a line in the southeast. On Tuesday, March 3rd, they were evenly spaced with Jupiter in the middle. Mars, the upper planet, is the one that's moving in relation to the other two, and it is moving eastward at nearly a degree a day. By the end of March, Mars will have passed by both Jupiter and Saturn. The International Space Station is visible in the morning sky, sometimes with 2 passages per morning for those in the higher latitudes of the northern hemisphere. For those closer to the equator, you won't see the International Space Station until early next week. Then you'll see it in the morning sky. Those in the southern hemisphere will find the International Space Station in the evening sky this week. To find out where it will be in your sky, go to this website, heavens-above.com, enter your location, and find out where and when to see it. Get out there and wave to the astronauts. Daylight savings time starts on Sunday, March 8th at 2 a.m. This affects those in most of the states in the United States, but not in the rest of the world. What we do is to change clocks at 2 a.m. to 3 a.m. What does this mean astronomically? In the evening, if it was getting dark at 7:30 each night, and that time does depend upon your latitude and your placement in your time zone, it will now get dark at 8:30 instead. So when you go out observing in the evening, you get a later start. And if you go to bed right after observing, you'll be getting to bed an hour later. Due to the sun moving further north each day, the time of twilight will continue to grow later and later each day until mid-June, when it will be 1 to 2 hours later, perhaps 10 p.m. or even later than that. For those of us who go out in the morning for astronomy, the morning twilight will be an hour later, say 6:30 instead of 5:30. Now might be a good time to get out and see the morning planets. And over the next few months, it will get earlier and earlier each morning until it is about 4 a.m. in June. Changing the clocks forward each spring and then back another hour each fall is a practice that has been going on in the United States for many, many years. Some states, some portions of the country have tried to do away with it, and not every state even practices this change of time twice a year. I live in Arizona, and in Arizona, we have what's known as Mountain Standard Time all year around. So we do not change our clocks, but most of the United States does. If your region or country does not change your clocks every 6 months, I would recommend personally that you keep it that way. For these next 3 items, you might want to download Podcast 9, Map 2, Moon. That's Podcast 9, Map 2, Moon. You can find this on my website, donmachholtz.com. There has been talk over the past few years of water on the moon, but what we'll be discussing is different than that. Large portions of the moon are called oceans or seas, or originally they were called mares, and this week we're going to go out and learn a few of them. They're not really oceans or seas of water, but they may resemble them somewhat in appearance. 300 years ago, astronomers with telescopes inferior to ours thought they were actually seas of water on the moon. They cover about 15% of the lunar surface, and they're more prominent on this side of the moon for some unknown reason than on the other side of the moon, which we never see. Actually, they are lowlands, plains where lava has filled in, basins of hardened lava. You might think of the mares as being the lowlands and everything else being a bit higher. Map 2 from Podcast 9 is a moon map from the BBC. It has the seas of the moon marked, and we will be using that when we observe the moon this week. Our unaided eye challenge, binocular challenge, and our telescope challenge all involve seeing these seas. Now, as you look at this moon map, when the moon is a crescent in our evening sky, only the far right-hand side is illuminated. You might see the left side in the center of the moon very faintly, and if so, that is called earth shine. That is sunlight reflecting off the earth that is shining on that part of the moon. Meanwhile, the very bright portion of the moon is lit by direct sunlight. So working from right to left on the moon map, the first sea we come to is a sea of crisis, sometimes called the Sea of Storms. But we will call it the Sea of Crisis so as not to confuse it with the Ocean of Storms, which we will look at later. This isolated sea appears as a circle, but we are looking at it near the edge of the moon. It is actually more like an oval extended away from us. It's about 350 miles running north-south. As the moon makes a slight east-west wiggle each month, some months this region is more easily visible than at other times. Next, we have 4 seas that are connected. Together, they make what is often referred to as the man in the moon. 2 seas make his legs, one his torso, and one his head. He's standing there looking at you. The 2 that make up his legs are the Sea of Fertility and the Sea of Nectar. Now, the Sea of Fertility doesn't stand out very well, but it is one of the larger seas. The Sea of Nectar is one of the more difficult ones to pick up. It's not very large, and it's not very dark. Now, the Sea of Tranquility, spelled with 2 L's, is a real place on the moon. It is in this sea that Apollo 11 landed, and that location became known as Tranquility Base. The next sea is a Sea of Serenity. It's near the top center of the moon and makes up the head of the man in the moon. This one measures about 400 miles across. Next to the Sea of Serenity is a smaller one near the center of the moon. It is known as the Sea of Vapors. This is one of the smaller ones. It's about 140 miles across. Towards the south end of the moon, we see our next sea, the Sea of Clouds. It lies between the craters Tycho and Copernicus. The Sea of Moisture is next, and it can be seen best when the moon is near full phase. It's about half the size of the Sea of Clouds. That is, it is about 230 miles across, and yet it stands out better than the Sea of Clouds. Now we move north for a large prominent sea, the Sea of Rains. This is my favorite sea. It has a lot of interesting items around its edges. There is a bay on this Sea of Rains, and it's known as the Bay of Rainbows. See if you can find that one. There is nothing that really separates this bay from the Sea of Rains, but it does stand out, and it is easy to see. At the very far north, we find the Sea of Cold. It appears long and thin, and you may have some difficulty tracing all of it out. Finally, we have an area so large that it's bigger than a sea. It is an ocean. It's known as the Ocean of Storms. So there you have it, 1 ocean, 10 seas, and 1 bay. Our unaided eye project this week is to find and identify all the seas on the moon. Using Moon Map 2 of Podcast 9, download that and see if you can find them. The best time would be when the moon is nearing full, which is going to be March 9th. Go out and spend some time and see what you can see with the unaided eye. Certainly the man in the moon should be fairly prominent. Now that's made up of 4 seas, and I suggest you begin there. And from there, using the moon map, work your way around the moon and see if you can identify all of the seas, the ocean, and the bay. Our binocular challenge is to use binoculars and holding them very steady, see if you can find and identify all of the seas. You'll notice a difference in the brightness and darkness of each of the seas, and you can rate them if you want from darkest to brightest, and which ones also tend to blend in with the background. Now, to identify them, have the moon map with you outside with your binoculars. Look through the binoculars, refer back to the moon map, back to the binoculars, back to the moon map, and learn your way around the moon. Learn the names of the seas and where they're located. Now, if you have a telescope, let's turn the telescope to the moon and let's examine the seas on the moon. With the moon so bright this week, you might want to use a moon filter or stop down your aperture a bit so it's not so bright. You will see a few rays on the moon, and these rays become more prominent as the moon becomes more full. Do these rays extend into the seas? And you also might notice fewer craters in the seas. Let's talk about local astronomy clubs. Now, there's hundreds of astronomy clubs in the U.S. and hundreds more around the world. If you haven't already, I suggest you find an astronomy club near you and attend a few meetings. My knowledge and experiences with astronomy have been enhanced with my involvement in astronomy clubs. Now, an astronomy club is a local group of folks who have an interest in astronomy. Groups can vary in size from 5 to 700. Typically, when I give a talk to a local astronomy club, I often find an average of about 30 people at the meeting. Ages vary, and some clubs do have a junior division for young folks. You might even find some families in attendance. But you'll see a lot of older folks too. Quite often those older folks know a whole lot about astronomy. They won't brag about it, but sit and talk with them and you'll find out. Now, most astronomy clubs have meetings each month. Sometimes a meeting date is tied to the phase of the moon. And the most popular week for meeting is the full moon week when observing is otherwise difficult. Local astronomy clubs generally meet in the evenings, often at a public library or a community center. Some clubs meet at the local science center or at a community college. Now, meetings will vary in style and content because each club is different. Now, some are very formal and use the Roberts Rules of Order. They have a constitution and bylaws, but some clubs are much less formal. Most of them have officers such as president, vice president. secretary, treasurer, newsletter editor, outreach coordinator, speaker finder, and so on. Generally speaking, an astronomy club meeting will have some business announcements and a featured speaker sharing knowledge about a specific astronomy or space science topic. Many clubs will set aside time for a show and tell. This can be most interesting as members get up in front of the group and show their specialties. You can learn a lot from others, and you can show others about your specialty. Before I had my driver's license, my mom would drive me to the Mount Diablo Astronomical Association meetings in the Concord, California area in the 1960s. It was at those meetings that I learned about making off-axis telescope mirrors, grazing occultations where a star passes behind the north or south limb of the moon and is blinked out by the mountains and valleys of the moon. I learned about the speed of light and star formation. I learned a lot about astronomy, which some applied to what I was doing then in my observing of the sky, and some did not, but it gave me a good general knowledge of astronomy. You can attend any astronomy club meeting as a guest, usually for as long as you want. I've never seen anyone kicked out of a meeting. For a small annual fee, you can become a member. Before the internet was popular, this was the only way you could receive the newsletter, which most clubs publish each month. Nowadays, most clubs make their newsletters available to anyone on the internet, and most astronomy clubs do have a web page telling what they do. Some clubs have an observatory, and you have to be a member and be trained on the telescope before they'll give you a key to the observatory. Many clubs have what's known as a loaner telescope program. That is, over the years, people have donated telescopes to the club. No one in particular owns the telescope. The club more or less owns it and lends it out to whoever wants to borrow a telescope for a few months. But all in all, it's the people. It is in the astronomy club you'll meet other local astronomers. Suddenly you're not by yourself anymore. There's others who enjoy doing what you do. The diversity in astronomy clubs is great. Some do visual observing, perhaps specializing in double stars or solar system objects or faint galaxies. Some do imaging, which in the old days meant astrophotography, but nowadays means imaging with electronic means too, such as with a CCD or CMOS. And note, too, that some astronomy clubs have a subgroup that meet on a different night just to discuss astroimaging. Some of those in the club are specifically interested in building telescopes, are developing neat gadgets to make observing easier. Some don't do much observing, but spend a lot of time learning about astronomy and in astrophysics. It's the people who know about things that you don't know, and people who don't know what you know and can learn from you. And it's not just an exchange of knowledge. Get to know your fellow astronomers. They can be friends for life, astronomically and socially. If you wish to participate in a public star party, then it will probably be through your local astronomy club. A public star party is where one or more individuals set up telescopes to show things to the public. We will discuss public star parties in detail in a few weeks. Astronomy clubs also have private star parties for members only to get together and look through their own telescopes. We'll discuss private star parties also in more detail in a later podcast. If you find a local astronomy club that doesn't fit your taste, then find another one. Each club is different. And I've noticed too that many astronomy clubs go through cycles lasting 5 to 15 years. And it goes something like this. The club grows, the volunteers are eagerly involved, things go well for several years. Then some of the volunteers get tired of doing what they're doing or busy with other things or move away or pass away. Filling their position becomes difficult, and those remaining volunteers get worn out and begin to feel they're pulling all of the weight, and the club begins to suffer. This down phase doesn't last forever. the club generally re-energizes. It sometimes takes a different direction with new personalities and is back running normally. I've seen this happen to many astronomy clubs, and I'm sure many other organizations, not just those related to astronomy. One more thing. What you learn from other astronomers will enhance your own observing, but it is not a substitute for going out on your own for observing the sky by yourself. This is a mistake that some amateur astronomers make, and they miss the celestial events occurring on a nightly basis. The best formula for advancing your astronomical education and expertise is to both connect with a local astronomy club and get out there and observe the sky as often as you possibly can. A check on the brightness of Betelgeuse, or trying to detect a shadow cast by the light of Venus, looking up at the Pleiades with the binoculars, they all require just a few minutes investment of time and minimal equipment. Now for more fun with the marathon. More than 200 years ago, an astronomer named Charles Messier made a list of 110 galaxies, clusters, and nebula visible to him as he went about his comet hunting. The Messier Marathon is a yearly activity to observe all or nearly all of the 110 galaxies, clusters, and nebula in the Messier catalog in one night. This can be done any time of the year, and you can get at least 90 objects in one night, but the best time to do this is in late March of each year, and it does depend upon the moon phase. With the new moon on March 24th this year, most astronomy clubs will be doing this on either the 21st or the 28th of March. The Saguaro Astronomy Club of Phoenix, Arizona will be holding the ever-popular All-Arizona Messier Marathon on March 28th. You can go to their website at www.saguaroastro.org for details. That is spelled SAGUAROASTRO.org for details. They will have a swap meet and also a raffle there too. To successfully run the marathon, it helps to have an observing order. You can download one from my website. It is in Podcast 5, and it's called the MM, for Messier Marathon, the MM search sequence. For today's podcast, you might also want to download a couple maps, Podcast 9 Map 3 MM6, and Podcast 9 Map 4 MM7, which will be showing the Messier objects that we'll be discussing this week. If you want previous Messier Marathon maps, we begin doing the search sequence in Podcast 5. So if you go back to Podcast 5 and then 6 and 7 and 8 and download the maps, which are called MM, beginning with MM1 with Podcast 5, you will have on hand 7 different maps which take you through the first part of the Messier Marathon, beginning with the objects in the evening sky. Now, when we left off last week, we had seen the 4th set of the Messier objects in the Messier Marathon, and we had covered 70 of the 110 objects, most of them in the evening sky, but now we're beginning to head over to the morning sky. This week we'll be covering 17 more objects. We're now getting into the summer Milky Way. The first object we find now is M57. It's the Ring Nebula. It is small, about 1.5 arc minutes in size, and it is magnitude 9. We drop down a few degrees to get our next object, which is a globular cluster known as M56. Now we're going to pick up a couple open star clusters. Our next jump is a bit larger, M29, which is a tiny box of stars. There's fewer than 12 stars in this box, and it is an open cluster, and it's near the center of Cygnus. Our next move is M39. Now, this is an open cluster north and east of Deneb. It's a fairly large open cluster, and it does tend to blend in with the Milky Way. This is as far north as we're going to be going in the Messier Marathon. Everything else we see for the rest of the morning will be south of this location. We'll stop at the constellation Sagitta for the Dumbbell Nebula, also known as M27. Then we'll move a few degrees south for M71, which is a globular cluster which is rather loosely assembled. For our final objects for this podcast, we go to map 4 from podcast 9, which is known as MM7. So we're going to go for 5 globular clusters in the constellation Ophiuchus. I suggest we start with M12, then drop down 3 degrees to M10. This is one of the few sets of objects in which the Messier object with the higher number comes before the one with the lower number. They're only a few degrees apart. We then head over to M14, and then to the right a few degrees to pick up M107. Now M107, of the 4 that we've seen so far, M107 is the fainter and smallest of these last 4. Finally, we head down from M107 to M9. Now nearby M9 are 2 fainter globular clusters, NGC 6356 and also 6342, which is just south of M9. Now these 3 globular clusters may all be in the same field of view or within a degree or so of each other, but M9 is the brightest one in the area. Finally, we head further south to the constellation Scorpius. We'll find the small globular cluster M8. Then we go back to Antares and head over a little bit to pick up the brighter and bigger M4. From here we head 7 degrees over to M9, then drop 4 degrees to M62. These are 2 globulars of almost equal brightness. M62 will be closer to your southern horizon, but by this time of the morning it should be above the horizon and visible. Our final 2 objects in this session are bright, but they are close to the southern horizon at this time of the morning. They are the open star clusters M6 and M7. Now, they both look great in the telescope, with M6 being twice as far away as M7. M6 will therefore appear to be smaller, and the stars will appear to be fainter as M7. If they're not above your horizon just yet, wait a little while until they get above your horizon for M6 and M7. So there you have it. The first 87 objects of the Messier Marathon. You've covered 79% of the Messier catalog. By now we're well past midnight, and we're headed toward the morning twilight. We'll pick up with more objects next week. You have been listening to Looking Up with Don, podcast episode number 9. Number 9? Once again, the related website for this podcast is donmachholtz.com. That's where you get all the star maps, the search sequence, and they're all free. It is spelled donmachholz.com, 2 H's. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We will discuss what's going on in the sky. Our second to last segment as we work our way through the sky with the Messier Marathon. And we'll be looking at 2 or maybe 3 comets. And I'll talk about my electric socks. Funny stuff. Thank you for listening. See the skies this week. I'll see you next week.